Let's talk about math. For so many of us, it feels like this thing that's just locked away in a textbook, right? Well, today, we're going to explore how we can build a bridge from those abstract ideas in the classroom to stuff you can actually use in the real world. This isn't just about finding math hiding in plain sight, it's about learning how to use it like a powerful tool.
I mean, we've all been there, haven't we? You're staring at a page full of X's and Y's, and you're just thinking, when am I ever going to use this? It's a totally fair question. It really can feel like school math just exists in its own little bubble. But the truth is, the logic behind math is actually running in the background of so many of our daily decisions, a lot of the time without us even realizing it.
So, where is all this math hiding? Let's kick things off by just recognizing the pretty complex problem-solving we're already doing every single day, even if we don't call it math.
Okay, think about the kitchen. You're doubling a recipe for a dinner party. Seems easy, right? But that mental calculation you're doing, that's all about ratios. It's the exact same type of thinking a chemical engineer uses to take a formula from a tiny lab beaker to a massive factory vat. It's all about ratios.
Or how about this one? You're out shopping and you spot a jacket that's 30% off. Your brain instantly starts figuring out the deal. That gut check calculation is a perfect example of using percentages, the very same skill you'd need to understand things like interest rates or big economic trends. And it's not just chores. Even fun stuff can be a math workout. You know, when you're deep into a Sudoku puzzle, you're using logic to figure out the missing pieces. Well, that whole process, that's basically the heart of algebra, using what you know to solve for what you don't.
Okay, so we've established that math is everywhere, not just trapped in a textbook. So the real challenge is, how do we make that connection on purpose? How do we build that solid bridge from the theory to actually using it in practice?
And this is exactly where the idea of applied math comes in. It's an approach that's designed from the ground up to build that bridge, to help you go from just someone who can remember the rules to someone who knows how to use them to solve real problems. Now, this is the crucial part. Applied math isn't about learning a bunch of new, super complicated formulas. No, it's about learning a new way of seeing the world. It's about spotting the mathematical bones of a problem and then picking the right tool from your toolkit to solve it. It connects the what with the why and the how. So a really effective applied math program usually zooms in on those big foundational ideas we just saw. You've got ratios, which are the key to understanding scale. You've got percentages, which are basically the language of money and data. And of course, basic algebra, which gives you the logical framework to solve for any unknown. But look, building this bridge isn't just about the concepts. You absolutely need the right tools and the right methods, because it's not just what you learn, it's how you learn it that really makes the difference. And here's the game changer. We're talking about a total shift away from the old school one-size-fits-all classroom. The new way is all about you learning at your own pace until you've truly mastered a concept. You don't move on until you're ready, which builds this incredibly strong and confident foundation. This new way of learning uses some seriously cool tools. For example, something like Polypad. Think of it like a digital playground for math. It lets you actually move numbers and shapes around, making those abstract ideas feel real and letting you see the patterns for yourself. And then there's the teamwork part, which is so important. Tools like QThink give you a space to share how you're solving a problem and see how other people are tackling it. You know, sometimes the best way to really understand something is to try and explain it to someone else. So, let's say you've done it. You've used these tools, you've followed this new path, and you've crossed that bridge from theory to practice. So, what's waiting for you on the other side? What's the big payoff? Well, the journey itself creates this amazing upward spiral. First, you learn the core idea. Then you really get to play with it using visual tools. After that, you sharpen your understanding by talking it over with others. And then, the most important step, you apply it all to a messy, real-world problem. The result? It's not just getting the right answer, it's building this deep, real confidence in your own abilities. And that really is the whole point. The goal isn't to turn everybody into a pure mathematician. It's to empower every single person to be a better, more confident, and more skilled problem solver, no matter what they do, using math as one of the best tools they have. So, I'll just leave you with this question. Now that you're starting to see the math that's hiding all around you, in your budget, in your hobbies, in your job, what's the first real-world problem you're going to go out and solve?